Today we have a Bitmain power supply 12 volt, output 12 volts, 100 ampere maximum, input 240, 10 ampere. There will be no voltage output when powering on the power supply. So most of power supply we can connect a control board to the power supply, and then we can upgrade the power supply by using the special firmware for the central board. But this power supply, there is no control board to do that. So we need to open, for this faulty power supply, let's first remove the power screw. There is 3 screws here and 3 here. Let's test the power cord. I have AC, I have 206, and if we plug to the power supply, nothing, the fan not working, not spinning, and here we don't have anything. It should indicate 12 volts here. DC mode, and it's nothing. So let's first remove the power screw. Also, there is a damage here on the electrode. A lot of damage here. We need to replace also this electrode with a new one. We received our Z17E power supply not working. Most of them issue on the control board, the board. So there is one screw here. And we need to open there is a 1, 2, 3, 4, 5 screw here. We need to remove all screwdriver here. Also, we have 4 screw fan. Should take it out. Sometimes the fan is spinning normally, but has no 12 output here in the board. This means that the power grid voltage is low, or the power supply is in protection mode. We will talk about that. So after we remove all the screws and take out the circuit board, this is a circuit board, and of course we need to remove the fan. there is a silicone here. You can just pull out. And be careful here, there is a coil, just a little bit, and everything will be good. Okay, this is a screw. Remove everything from this board. We took out the electrode. Now let's start to check every component. So in AC mode, we test the AC line. Fuse. Here we have a fuse, and let's test the fuse. Continuity mode. So AC line 220, there is a fuse here, protection, and capacitor 2 coil for filter, and then 2 capacitor 450 volts, and after that this AC line, it will manage all this power supply here. So this power supply is a small power supply here, coil and a small transformer. This should only always on, and it will manage all this component here. So we test the fuse. Here we have a silicone, as you can see here, for protection. So we need to test the fuse first. So the fuse is working good. And the power here, this is a ground. And if we test here, AC mode 209. Okay, be careful from this capacitor, 200. So here it's good. After we test the power line AC, we need to measure whether the positive and negative poles of the output terminal are shorted circuit or not. If there is no shorted circuit, so we measure whether there is a voltage input in the front section. So we talk about this side. So this is AC mode and this is DC mode. At AC we need to test if the diode is shorted. Diode and not shorted. Okay, it's good. Then we test the two cap here, big cap. Okay, so we need the input voltage is measured on the 2 pins of the large capacitance here. So we need to measure whether the input voltage is about 420 volt. If we have in the 2 cap here less than 420 or less than 350, like 300 volt, it indicates that PFC has no pressure rise. So the power PFC, it's a power factor correction. So let's test these 2 cap. If it's good, then the whole circuit here it's good. Then we detect the DC mode. Maybe there is a malfunction here. So we put in DC mode. So we have 377. It's good. So here, two pin of the large capacitor. And we have 377, and here we have 377. So 2 cap it's good. If the 2 cap it's good, so normally all VCC here it's good. Sure, if in order to ensure the safety, it is necessary to discharge the capacitor here. So I put a continuity mode, and then we discharge the capacitor. Okay. Test the volt here. So nothing, that's good. So I check the control board for short circuit or faulty soldering. So control board chip circuit is powered by the VCC, which is voltage common collector, is the higher voltage with respect to the ground. So VCC is a power input of power input. It may be positive or negative with respect to the ground. So it's necessary to detect whether the VCC power supply is normal. So all this part is good. We have to check the DC mode from here. So 2 cap it's good. Let's check the bridge rectifier if there is a shorting or not. Nothing, it's good. And this one is good. Also this one is good. So what could be the issue of this power supply? Here I didn't see anything obvious or any damage or any Hiroshima bomb. So let's check the diode. Of course, measure whether the diode transistor of the VCC circuit is normal. If it didn't work, it should be replaced. Our measurement work. So first let's check this chip here. It's control chip. We one probe is to ground and the other one measure the same pin position of 4 driver chip here and compare them. So the value of the same pin of the normal chip is basically the same. So if we put power supply back, okay, 12, okay, fine. So at this chip I have a 12. I have a 12 on the chip, so it's normal, it's good. The control chip, it's good, working good. So what could be the issue? It's after the chip, and after the chip it's here. So let's unplug the power cord and let's check the short circuit. Most likely we have a diode damage. Oh, there is shorted here. We detect a short here. So this diode, no, it's not shorting. No, it's not shorted. Okay, because it's a fully charged and now it's discharged. Okay, it's normal. Let's check here. Okay. Okay. So maybe we find the issue is from these two diodes. One of them is shorted, but before we need to see if this is parallel or not, we need to put a probe here and here. Okay, it's not a parallel. See, so one is ground and the other is not a ground. So if we test from here to here, it's shorted. So let's try to remove this diode and see what happens. Now it's nothing. Okay. So now it's nothing. We need to know the polarity of this diode, negative from here and positive from here. So let's try now. Okay, finally we have a 12 volt. So we have output voltage 12.4. Okay, and the two side, and the two terminal. Also, everything is good. Let's try to put a fan. This fan is a 12 DC, and if we measure the output of the fan, it indicates 8.4. So the fan is spinning. If the power wow. So the fan is spinning. If the power output of the power supply is normal, but the span is not spinning, high chance that fan are malfunction. So everything is good, the 12 volt, and it's constant. I'm waiting just if anything happen or anything, if there is drop in voltage, but it's constant as you can see here, 12.46, 12.47, it's normal. So here we can find, I have a lot of the power supply. We need to check. More than 80 power supply is malfunction, not working. Most of them issue on the board. I have replaced before the most bridge rectifier here, and sorry, this is not a bridge rectifier. This is a transistor. This is a bridge rectifier here, as you can see here. And here is a diode, and here is a transistor.